Okay, so here we have the question. Investigate the stationary points on the curve, stating the coordinates and the nature of each type of stationary point. So the curve we're going to look at, first of all, is y equals x plus 1 over x. So stationary points are either a maximum or a minimum turning point. That's what we're looking for. Okay, and in order to find those, we're going to find dy dx, so we're going to put them equal to 0. And then to investigate the nature of those turning points, we're going to find the second derivative. So we're going to differentiate again. If the second derivative gives a value which is greater than 0, we will find that it's a minimum. And if we find that the second derivative gives a value less than 0, then it's a maximum. There is another incident as well, but it's equal to 0, but we're not going to deal with that one today. Okay, just erase that. Okay, so this needs to be readied for differentiation. So we're going to rewrite the 1 over x as a power, so x to the negative 1. Okay, it is now ready to be differentiated. dy dx is 1. I'm going to show every step in this. So we bring the power, the negative 1, in front, and then we take away 1 from that power, which gives us 1 minus x to the negative 2. I'm actually going to write that like that because we're going to put some values in, or we're going to try and find some values. Okay, so that's a stationary point. Dy dx needs to be 0. So we need to solve that for x. A number of ways to do this. I'm going to do it this way. And then, since both sides are negative, we can multiply through by negative 1, making it all positive, and we multiply it through by x squared as well. We could solve it like that. I'm actually going to use a difference of 2 squares, so that can now be factorized. And that tells us that there are turning points when x equals 1 and x equals negative 1. We were actually asked to find the coordinates of the turning points, so we need to find the y value. So when x is negative 1, y is equal to negative 1 plus 1 over negative 1, and that gives us negative 2. So there's a turning point at negative 1, negative 2. And when x is equal to 1, y is equal to 1 plus 1 over 1, which is 2. So there's a turning point at the coordinates 1, 2. Okay, so we need to investigate the nature of those turning points. Is it a maximum or minimum? So just to remind you, dy dx was 1 minus x to the negative 2, and we're going to differentiate again. And when we differentiate again, the 1 disappears. We'll keep the negative, bring the negative 2 in front, and take away 1 from the power, and that gives us 2x to the negative 3, and we're going to write that as 2 over x cubed because I'm going to put those values of x into there. Okay, so that's the second derivative. We want to find the nature of the 2 turning points. So let's look at when x is negative 1, the second derivative is 2 over negative 1 cubed. Negative 1 cubed is negative 1. 2 divided by negative 1 is less than 0. Therefore, it's a maximum. And when x equals 1, the second derivative is 2 over 1 cubed. 1 cubed is 1. 2 over 1 is 2, which is greater than 0. Therefore, a minimum. I'm actually just going to sketch that curve just to show exactly what's going on here. Because actually ultimately what we would want to do probably is to sketch the curve. We're told, we've worked out that we have a maximum when x is -1 and y is -2, and that's a maximum, so it's going to look like that. And then we have the minimum when x is 1 and y is 2, so we have a minimum like that. Just to go back to the original curve, can you see that when we can't ever divide by 0, so if x equals 0, we can't do that because it would be tending towards infinity. So as x tends towards 0, the y value 1 over 0 tends towards infinity. So as we get small values of x there, we have an asymptote, and then we can see it looks like that. The question didn't ask us to do that. Okay, now for the second curve, we're going to investigate the turning points. We've got 3x to the half, 4 minus x to the 3 over 2. Now, it doesn't say this in the question, but just to note, we're taking the square root of x, that's x to the half. So just to remind you, x to the half is the same as the square root of x. So we're taking the square root of a number, and we can't take the square root of negative numbers. So x, for this question, x is greater than 0. Okay, so we're finding the nature of the turning point. Just going to prepare this to be differentiated. I'm just going to write just a small change there. Right, the 3 divided by 4 is 3/4. And now we're going to differentiate. Keep the 3/4 there. Bring the half in front, and take away 1 from the power. Bring the 3 over 2 in front. Take away 1, which gives us 1/2. We need to put that equal to 0 because we're finding the turning points when the gradient is 0. Okay, lots of ways of doing this. I'm going to do it this way on this occasion. Because we're trying to find values of x, we're going to first of all multiply through by -1, so both sides are now positive, and then it's going to be 3/8 the square root of x is equal to 3 over 2 root x, multiplied by root x on both sides, multiplied by 2, divide by 3, and x is equal to 1/4. Okay, so when x is 1/4, we wanted to find the coordinates, we need the y value. So we'll put it into that one there. So x is equal to 1/4. I'm just going to write it with the square root sign, because we're going to be putting a value in. So 3/4, the square root of 1/4 minus the square root of 1/4 cubed. The square root of 1/4 is 1/2. So 1/2 cubed. And y is equal to 3/8 minus 1/8, which is 2/8, which is 1/4. So the coordinates of the turning point, 1/4, 1/4. Now we've been asked to find the nature of that turning point. So we need to differentiate again. So just to remind you, dy dx, we had found that to be 3/8 x to the minus 1/2 minus 3 over 2 x to the half. We'll keep it in powers because we're going to differentiate. So take the second derivative, 3/8 negative 1/2 x, take away 1 minus 3 over 2 minus 3 over 2, put the half in front and take away 1. This gives us negative 1/2. And we're going to simplify that. Negative 3/16 x to the negative 3 over 2 minus 3/4 x to the negative 1/2. We're going to put in the value of x is equal to 1/4, so I'm going to write it in terms of square roots actually. So x to the 3 over 2 minus 3 square root of x. No, I am going to do that. Let me just write it there. X to the half, which is negative 3/16 the square root of x cubed minus 3/4 the square root of x. Okay, now we're going to find the values of the second derivative when we put in, or the value when we put in x equals 1/4, and we're only concerned whether it's negative or positive actually. So negative 3/16 the square root of 1/4 cubed minus 3 square root of 1/4. Now the square root of 1/4 is a half. A half cubed is going to be positive. 16 times, that is positive, but it's negative 3, so the whole thing is negative. And we're going to take away, and since this is positive here, we're taking away a positive, so the final answer is a negative, i.e. less than 0, therefore a maximum. Obviously in a test you probably have to put those values in, but that's what we had to do. So now, in terms of sketching this, just to remind you, the original curve was 3x to the half over 4 minus x 3 over 2. Actually, I did say that it's greater than 0, isn't it? It's greater than or equal to 0. And notice when you put x as 0 in there, you get 0. We've got a turning point at a quarter, so it seems to do that. And we can see that as x gets bigger, the values of y become negative because of that is greater than that.